Hello everyone. In this video, we'll learn subset construction method which is used to convert a non-deterministic finite automata machine into deterministic finite automata machine. So let's take an example. Example will be much more meaningful to understand the concept of subset construction method. So let's say a language L which starts with A. So first of all, we draw the transition diagram as well as transition table for this language, and after that I will use subset construction method to convert the transition table as well as transition diagram into DFA transition table and DFA transition diagram. So till now I have not take any transition table example, but you can understand that transition diagram is a way of representing the automata machine. Similarly, you can also represent the various automata machine with the help of transition table. Okay, so transition table and transition diagram both are similar, but they are a way of different representation for the automata machine. So a language which starts with A, how can you draw the NDFA? In the previous video I have already taken this language. So what you will do here, A is the initial state, then on small a it will go to the final state capital B, and on capital B it will take any number of A's or any number of B's. So this is the transition diagram for this language, and it is nothing but NDFA. Remember that first we draw the transition diagram of NDFA, then this transition diagram is converted into transition table. How can you draw the transition table? Transition table on the row side, that means row contain always state and column contains the input alphabet. So there are two states in this particular transition diagram, capital A and capital B. And initial state is represented with an arrow symbol before the state name. Okay, and if you want to represent final state, then you can represent with star. Okay, and on the column small a and small b are the two input alphabets. Okay, now first we will cover the row number 1. Row number 1 contains capital A. Capital A is the initial state. On capital A, if you see A, you will go to the state capital B. Okay, and what about the symbol small b? On small b, it doesn't have any move. That means it is a dead configuration. For dead configuration, I will use the symbol 5. Okay, now let's take row number 2. Row number 2 is final state capital B. Capital B, on seeing small a and small b, will go to the same state capital B itself. So here I will take capital B and capital B. Now from this transition table, I can easily convert into DFA by using subset construction method. So here I will draw the transition table of DFA. In DFA, I will start with the row number 1. Okay, not blindly copy all the rows. You will always start with the row number 1, and if any other row is added, then you can add after the row number 1. Okay, so let's say row number 1 is capital A, and there are always two input alphabets, small a and small b. Capital A on small a will go to the state capital B, and remember that in non-deterministic finite automata machine there is a concept of dead configuration state. Dead configuration state means for some input there is no any move defined here. But in a deterministic finite automata machine, there is no dead configuration concept. Here we have dead state. Dead state means for any input, if we do not reach a final state, if we reach a non-final state, then such state is called dead state. Okay, so here dead configuration is converted to dead state. Let's call dead state is D. So assume that D is our dead state, which is in previous transition diagram table. It is dead configuration. Now I will cover the state B and state D in separate row. So here the next state is decided based on the row number 1 steps. So in row number 1, if you take let's say if you take a move on some input alphabet and you got the new state, then you will consider this new state as the row number as the next row number. So here capital B is our next state. On capital B, here if you consider capital B on small a and small b, will go to the capital B itself. Capital B and capital B. So I will cover row state capital A, state capital B. What is left? State capital D is left. So I will take capital D. Now here there is no state capital D. Here state capital D is dead state. So on dead state, the move is on its dead state itself. What I mean to say here, if you take small a and small b on the dead state, then the dead state will go itself by using this input alphabet. Okay. Now our transition table is over. Using the transition table, I can easily draw the transition diagram. Transition diagram contain 3 states: A, B. B is our final state because in previous transition table NDFA, B is the final state, and here A is the initial state. So A is our initial state, B is our final state, and D is our dead state. On small a, I will go to the state B. On small b, I will go to the state D. Capital A will take move on A and B to itself. Similarly, on D will take A and B move on itself. Okay, so this is the transition diagram of deterministic finite automata machine, which takes a language in which the starting symbol is A. Okay, so I think you got the point of subset construction method, how to draw the transition table and transition diagram of DFA from NDFA machine. Okay, similarly I can take some other examples also. In the previous video we will see one more example related to subset construction method.